Welcome to harichemistry. So this is lecture number 2 in colligative properties. The topic is osmotic pressure. Okay, so in this topic we will discuss what is osmosis and the types of osmosis and what is the role of semi-permeable membrane in osmotic pressure and reverse osmosis, and then what is the difference between diffusion and osmosis, and then we will move to the osmotic pressure and the calculation of molecular mass in osmotic pressure. Okay, clear student? Right. So what is meant by osmosis? Okay, so what is meant by osmosis? Osmosis means the flow of solvent molecules from a solution of low concentration region to high concentration region through a semi-permeable membrane is called osmosis. Is that clear, student? So what is osmosis here? For example, so this is a semi-permeable membrane. So this is a semi-permeable membrane. So here the flow of solvent molecule. So this is a low concentration region. So this is a low concentration solution. So this is a high concentration region or high concentration solution. Here, so the flow of solvent molecules from low concentration region to high concentration region through a semi-permeable membrane, so we can call it osmosis. So osmosis means nothing but, student, the flow of solvent molecules from low concentration region to high concentration region through a semi-permeable membrane is called osmosis. Clear, student? Right. So generally the osmosis process is classified into three types. Osmosis is classified into three types. That is exoosmosis. The second one is endo osmosis. The third one is reverse osmosis. So exoosmosis, endo osmosis, and reverse osmosis. Clear, student? Right. So what is exoosmosis? So exoosmosis means nothing but the process by which water molecules move out of the cell. The water molecules move out of the cell is called exoosmosis. So what is exoosmosis, student? The process by which water molecules move out of the cell is called exoosmosis. Okay, so then endo osmosis. What is meant by endo osmosis? How we can define as endo osmosis process means nothing but the process by which water molecules enter into the cell is called endo osmosis. Clear, student? Right. In exoosmosis process, the water molecules move out of the cell, but in endo osmosis process, the water molecules enter into the cell. So that is endo osmosis process, right? So generally we will take an example, the case of endo and exoosmosis process, right? So take 100 ml of water in two containers. So this is 100 ml of water. 100 ml of water. So add sugar into this second container. So without adding sugar, so only we are taking water only. So take 3 to 4 raisins, and here take 3 to 4 grapes. So after 24, you can soak after 24 hours. So what will happen? The raisins which I have taken into this water glass, the raisins become swell. But here in this case, whatever the grapes we have taken into the sugar containing solution, the grapes becomes it decrease in their structure. So means what it indicates that here in this case the water is enter into the cell, means the water is moved into the rhizome, but here in this case here it is a endo osmosis process and this is a exo osmosis process. Here in this case the grapes leaves, it contain water, the water is flow into the solution, sugar solution, and it lost its water. So means here, so it decrease in shape of the grapes. So means here the water is out of the cell, but here in this case the water enters. The process by which water enter into the cell, that is endo osmosis. The process by which water out of the cell, that is called exo osmosis. Is that clear, student? Right. Okay. So then the third topic is reverse osmosis. What is reverse osmosis, students? So reverse osmosis means nothing but if we apply a pressure higher than osmotic pressure, we are applying a higher pressure is more than osmotic pressure. Therefore, the solution, what will happen? The movement of solvent molecules from higher concentration region to lower concentration region through a semi-permeable membrane. So here this is a RO process. So here it is completely reversed to the osmosis process. In reverse osmosis process, if we are applying high pressure is greater than the osmotic pressure on the solution, the flow of solvent molecules from high concentration solution to low concentration solution through a semi-permeable membrane, so is called reverse osmosis process. Okay, clear, student? Right. So then we will move to the what is a semi-permeable membrane and what is the role of a semi-permeable membrane. So generally the semi-permeable membranes are contains microscopic holes or pores. So generally, so these membranes are prepared in naturally available materials and we can prepare in artificially. So generally the naturally available semi-permeable membranes, natural semi-permeable membranes are pig's bladder and parchment paper. So these are the example for natural semi-permeable membrane. Okay. So artificial semi-permeable membranes are cellophane, silicates of cobalt, iron, silicates of cobalt, iron, and copper ferrocyanide. So these are the example for artificial semi-permeable membrane. Already we know very well what is the semi-permeable membrane. The semi-permeable membrane which can allows only the solvent molecules through them, but it cannot allow solute molecules through them. That is very, very important. Okay, clear, student? Right. So then we will move to the differences between osmosis and diffusion. Osmosis and diffusion. So what is osmosis and what is diffusion? We will. The flow of solvent molecules takes place from low concentration region to high concentration region through a semi-permeable membrane. Okay, students. So in osmosis process, here it is a semi-permeable membrane. So this is a SPM, semi-permeable membrane. The flow of solvent molecules takes place from low concentration region to high concentration region through a semi-permeable membrane. Okay, in diffusion, so what is mean by diffusion? In diffusion, the flow of molecules from high concentration region to low concentration region without semi-permeable membrane. Clear? So the flow of molecules from high concentration region to low concentration region without any membrane. But here, so the semi-permeable membrane is required. So that is the difference between osmosis and diffusion. So here we require semi-permeable membrane. So we do not require any membrane. So here the flow of molecules takes place from low concentration region to high concentration region. But here, so high concentration region to low concentration region. Clear? So here osmosis is limited for solutions only. Osmosis is limited for solutions only. But here the diffusion is applicable for liquids and gases also. So therefore the movement of these molecules randomly, so it cannot move in a Q manner. So the movement of liquid molecules and the movement of gaseous molecules, the movement takes place in random manner. Clear, students? So here it is applicable for solutions only, but it applicable for liquids and gaseous molecules. Okay, clear, student? In osmosis process we require semi-permeable membrane. So here not required for semi-permeable membrane. Okay, clear, student? Right. So and also in osmosis we can stop the osmosis process, or we can reverse the osmosis process by applying some external pressure. If we apply any kind of external pressure on the solution, we can stop the osmosis process or we can reverse the osmosis process. But here in diffusion process, diffusion can neither stop nor be reverse. So we cannot reverse or we cannot stop. So that is a diffusion process. We can stop or we can reverse the osmosis process, but in diffusion neither stop nor be reverse. So that is the differences between osmosis and diffusion process. Clear, student? Okay, student. So generally we know what is osmosis, student. So osmosis means nothing but the flow of solvent molecules from low concentration region to high concentration region through a semi-permeable membrane. Clear, student? So here, for example, the concentration of a solution C1 and the concentration of another solution C2. Okay, so here this is low concentration solution, this is high concentration solution. What is osmosis? The flow of solvent molecules from low concentration region to high concentration region through a semi-permeable membrane we can call osmosis process. Okay, clear, student? So let we see the diagram. Here this is osmosis, this is the diagram. Here you can see the flow of solvent molecules from one concentration to another concentration through a semi-permeable membrane. Okay, clear, students? When these two concentrations of the solutions attains equilibrium, when the two concentration solutions are reached to the equilibrium, then here we applied some amount of pressure to stop the flow of solvent molecules from one solution to another solution. The pressure we are applied is known as a osmotic pressure. Clear, student? For example, the solvent molecules are moved towards one solution to another solution through a semi-permeable membrane. When the concentration of solutions are equal, means when it reaches to equilibrium condition, then we will stop the movement of solvent molecules from through a semi-permeable membrane. If we applied some external pressure, the external pressure we can call as a osmotic pressure. Okay, clear, student? Right. So osmotic pressure is defined as Osmotic pressure is defined as the excess of pressure which is applied on the solution to prevent the flow of solvent molecules is called osmotic pressure. Clear, student? Right? So to prevent the flow of solvent molecules from through a semi-permeable membrane, here we are applying some external pressure. So the pressure we are applying to prevent the flow of solvent molecules from one concentration region to another concentration region through a semi-permeable membrane, the pressure we can call as osmotic pressure. Molecular mass of non-volatile solute by osmotic pressure. Okay, student? Right. So here we will derive the molecular mass of a non-volatile solute from osmotic pressure. Okay. So clear, student? Right. So according to the Van Hoff's Boyle's law. According to the Van Hoff Boyle's law. So we know very well about Boyle's law. So Boyle's law is P is inversely proportionality to 1 by P. So according to the Van Hoff Boyle's law, that is osmotic pressure is inversely proportionality to the 1 by P. So here the volume of the solution increases, the osmotic pressure will be decreases. So just let us assume the equation number 1. Clear, student? Right. So next, according to the Gay-Lussac law, according to the Van Hoff Gay-Lussac law. So what it say? So P is directly proportionality to the temperature. So means the pressure is increases, temperature will be increases. So according to the Van Hoff Gay-Lussac law, that is pi is directly proportionality to the temperature. So just we can assume that is equation 2, that is pi is inversely proportionality to 1 by V and directly proportionality to T. So here we will write so pi is equal to K into 1 by V into we can write S into T. Pi is equal to S into 1 by V into T. So that is equal to S is equal to nothing but solution constant. S is equal to nothing but solution constant. Okay, so we will write pi V is equal to S into T. But we know very well that is but V is equal to 1 by V. C is equal to, we will write 1 by V. So C is equal to 1 by V is equal to, we will write that is concentration. Concentration means nothing but N moles, number of moles by volume of the solution. So means here we will write N number of moles of solute present in V liters of solution. That is nothing but concentration. What is, student, concentration? Concentration we will write in number of moles. Here we are taking only 1 mole. 1 mole of solute present in 1 liter of the solution. So that is equal to, in place of 1 by V, we will write pi is equal to C into ST. So this is the formula for the osmotic pressure. Pi is equal to C into concentration of the solution. S is the solution constant, T is the temperature. Okay, clear student. When we substitute the values of pi, C, T, so we will get the solution constant S. So here it is solution constant S. Solution constant S value is nearer to the gas constant R, nearer to the gas constant R. So therefore, in place of S we will write pi is equal to C into RT also. So we will write pi is equal to C into R2. So when we substitute the value of osmotic pressure and concentration of the solution and temperature, so we will get the solution constant value, so which is nearer to the gas constant value. So therefore, in place of S we will substitute R. So that is equal to, the equation becomes pi is equal to C into RT, student. Okay, right. Here generally the concentration of the solution, C is equal to nothing but, student, n moles of solute present in V liters of solution. So clear, student? So means n moles of solute present in V liters of solute. So therefore solution. So in place of C we will substitute n by V. So that is equal to pi is equal to C into ST, or we can substitute both the equation. That is equal to C is equal to n by V into S into T, or pi is equal to, student, pi is equal to n by V into R into T. Clear, student? So that is equal to pi V is equal to NST, or pi V is equal to nRT. So here it is gas constant, here it is a solution constant. Okay, clear, student? So both the values are same. Okay, so here in place of number of moles is equal nothing but, student, weight of the solute divided by molecular mass of the solute. So therefore pi is equal to pi V is equal to, n means nothing but, student, number of moles of solute divided by n is equal, that is number of n is equal to weight of solute divided by molecular mass of solution, molecular mass of solute. Clear, student? So that is equal to pi V is equal to W by M into S into T. So that is equal to pi V is equal to W by M into S into T. Okay, clear, student? Here also we will write pi V is equal to weight by molecular weight into R into T, student. So here we will calculate the molecular mass of the non-volatile solute. So that is equal to, we will get the molecular mass of non-volatile solute, that is M is equal to, that is pi by W, pi M is equal to W into ST by pi V. So this is the molecular mass of non-volatile solute. Okay, clear, student? Here also we will write M is equal to W, weight of the solute, into RT by pi into V. Here, so here we will substitute, R value is gas constant, here we will substitute solution constant. So weight is multiplied by solution constant into temperature is divided by osmotic pressure into volume of the solution. Here also molecular mass is equal to weight is multiplied by gas constant into temperature divided by osmotic pressure into volume of the solution. So this is the formula for the calculation of molecular mass of any non-volatile solute according to the osmotic pressure phenomena. Okay, clear, student?